Find a vector v parallel to vector u and with a magnitude of 6. This means we're looking for a vector v that points in the same or opposite direction of vector u that has a magnitude of 6, which must be a scalar multiple of vector u. Let's first write vector u in component form. Vector u has an x component of 4 and a y component of -1. Now again, vector v is going to be a scalar multiple of vector u, meaning c times vector u, where c is a scalar. So we can write vector v as c times the vector in component form, where the x component is 4 and the y component is -1. Performing the scalar multiplication, vector v has an x component of 4c and a y component of -c. So now we'll determine the magnitude of vector v, set it equal to 6, and then solve for c. So the magnitude of vector v is equal to the square root of the sum of the square of 4c and the square of -c. And we know this must equal positive 6. Let's go ahead and simplify under the square root. The square of 4c is 16c squared. The square of -c is c squared, giving us the equation the square root of 17c squared equals 6. The square root of 17c squared simplifies because c squared is a perfect square, but remember the result must be positive. The square root of c squared is equal to the absolute value of c, giving us the absolute value of c times the square root of 17 equals 6. Next we divide both sides by the square root of 17. Simplifying, we have the absolute value of c equals 6 divided by the square root of 17. This indicates that c is equal to plus or minus 6 divided by the square root of 17. So if we use the positive value for c, vector u will point in the same direction as vector u and have a magnitude of 6. If we use the negative value of c, vector v will point in the opposite direction of vector u, but still have a magnitude of 6. And both vectors will be parallel to the given vector u. So to finish, our vector v, let's use the positive value of c so the vector points in the same direction, and therefore the x component would be 4 times 6 divided by square root 17, and the y component would be -6 divided by square root 17. Simplifying one last time, the x component is 24 divided by square root 17, and the y component is -6 divided by square root 17. This is a vector v that is parallel to vector u and has a magnitude of 6. Before we go, let's go ahead and check the magnitude of vector v. And here we see the magnitude of vector v is equal to positive 6, verifying our work is correct. I hope you found this helpful.